All right, let's take a look at 7.4, Trigonometry, Ratios and Missing Sides. So make sure you have your note packets out. This is the lesson that we looked at last Friday, so for anyone who is absent that day, you can watch this and get yourself caught up. Now, one thing that you're going to need as well as your note packet is your scientific calculator. If for some reason you don't have your TI-84 with you, you can use a scientific calculator by going to www.desmos.com and clicking on Scientific Calculator. Let's go ahead and begin our lesson. So the learning target today is that we're going to apply the trigonometric ratios of sine, cosine, and tangent to find the lengths of missing sides of right triangles. Now you might not know what sine, cosine, and tangent mean, but we're going to learn about that today. On your calculator they're abbreviated SIN for sine, COS for cosine, and TAN for tangent. You can probably find those buttons on your calculator now. But first, let's define what is trigonometry. So in those two empty blanks on your note page, write this. Trigonometry is the study of the mathematical relationships involving lengths and angles of triangles. Take a minute, you can pause the video and write that down. Alright, now let's get into the three trigonometric ratios, sine, cosine, and tangent. Now pay careful attention because what's over here, right, these definitions very much tie back to this diagram here. In fact, before we read any of this, let's look at the diagram. I want you to notice that there are both uppercase letters A, B, and C and lowercase letters A, B, and C. As you'll note, the uppercase letters represent angles, angle A, angle B, and angle C. And across from each angle, across from angle A, is lowercase a, that is side A. Across from angle B is lowercase b, that would be side B, and across from angle C is lowercase c, which of course is side C. Now that side C, as you think about Pythagorean theorem, a squared plus b squared equals c squared, that tells us that this side is the hypotenuse. Now, let me just erase some of those markings because we will need to mark this up a little bit differently in a moment, but that's an important thing to remember. Let's go ahead and look at the definition up here. It says each acute angle of a right triangle. So a reminder, these trig ratios only work in right triangles, and we're specifically talking about the acute angles, the angles less than 90. So each acute angle of a right triangle has the following trig ratios. Remember, a ratio is like a fraction, like, A over B or 5 over 7, okay? Now look at the definition of sine. It says it's the ratio of the leg opposite the angle to the hypotenuse. So if you were to write that down, you could write opposite over hypotenuse. I would encourage you to write that down right here for now. Now what exactly are they talking about, this opposite leg and the hypotenuse? Well, here's what I would encourage you to do. We're going to begin by looking at three examples: sine of angle A, cosine of angle A, and tangent of angle A. You'll notice those three examples have the same thing in common. They're all paying attention to angle A. So I would encourage you with a pencil, hopefully, not a pen, I would encourage you to circle angle A. Okay? I think we would all agree that side C, lowercase c, is still the hypotenuse, but the other two legs are going to get classified either as the opposite leg or the adjacent leg. So opposite from angle A would be lowercase a. We talked about that earlier. Adjacent to angle A is lowercase b, this side here. So this is the adjacent leg, this is the opposite leg, and this is the hypotenuse. Now look at the definition again of sine. It says the ratio of the leg opposite to the hypotenuse, or just opposite over hypotenuse. So sine of angle A in this case, opposite over hypotenuse, is lowercase letter a over lowercase letter c. Now let's look at the definition of cosine. Cosine is the ratio of the leg adjacent to the angle, to the hypotenuse. So if you want to write that down, you could write adjacent over hypotenuse. Looking at our diagram, that would be lowercase b over lowercase c, the adjacent leg over the hypotenuse. And then the definition of tangent. Tangent says the ratio of the leg opposite to the leg that's adjacent. So if we write this down as a little formula, it's opposite over adjacent. Looking at our diagram, opposite is lowercase a, And adjacent to angle A is lowercase b. Now, those are our formulas, but what you'll notice is we did sine of angle A, cosine of angle A, and tangent of angle A. What happens when we pay attention to a different angle to begin with? Well, I encourage you, hopefully you wrote in pencil the first time, let's erase that circle around angle A. We were paying attention primarily to angle A earlier. Now let's pay attention to angle B. Now when I do that though, something needs to change. First, C is still the hypotenuse. That doesn't change at all. But you'll notice that lowercase a is no longer the opposite leg, right? It's lowercase b that is opposite of angle B. So we need to erase these classifications. They have switched now. Now lowercase b is the opposite side, and lowercase a is the adjacent leg. Make sure you switch those up. Pay attention to which angle you're working with from the beginning. Sine of b, cosine of b, and tangent of b. So let's fill those in. So sine of angle b, again, the formula is opposite over hypotenuse. In this case, that'll be b over c. Cosine of angle b, remember that's adjacent over hypotenuse. In this case, that's a over c. And finally, tangent of angle b, that's opposite over adjacent. In this case, that's going to be b over a. Now, hopefully you were able to follow that, but the question becomes, how are we supposed to memorize this? How are we supposed to remember that sine is this, and cosine is this, and tangent is this? Well, I have what appears to be a nonsense set of words that are really abbreviations. In this first blank down here, I want you to write the word so, but I want you to spell it S-O-H. And then in the second blank, I want you to write ka, spell it C-A-H. And then in the last blank, I want you to write toa, so-ka-toa, so-ka-toa. Seems like just nonsense words, but they actually stand for something. The S stands for sine, the O and the H stand for opposite over hypotenuse. So means sine of an angle equals opposite over hypotenuse. Likewise, C stands for cosine, A stands for adjacent, and H stands for hypotenuse. So ka means cosine equals adjacent over hypotenuse. And then tangent, or toa, the T stands for tangent, the O stands for opposite, and the A stands for adjacent. So toa means tangent equals opposite over adjacent. If you can memorize so, ka, toa, you will have memorized all three trig ratios that you need for honors geometry. All right, now let's see a few examples. Down below, we're going to look at examples 1 and 3, okay? As we look at example 1, let's start with the examples in this first column, sine of A, cosine of A, and tangent of A. That means that we should circle angle A and classify the other sides. So 13 is the hypotenuse, 5 is the opposite leg, and 12 is the adjacent leg. Now remember, so, ka, toa, so, ka, toa. If we're looking at sine of angle A, that would be opposite over hypotenuse. In this case, that would be 5 over 13. Cosine, that's ka, or adjacent over hypotenuse. In this case, that's 12 over 13. And finally, toa. Remember, that's tangent is opposite over adjacent. So in this case, that's 5 over 12. Now, as we look at the next set of examples, you'll notice that now we're paying attention to angle C. I would encourage you to take your pencil and erase the circle we put around angle A and now circle angle C. We also need to change some of the classifications, right? 13 is still the hypotenuse, but now across from angle C, or opposite of angle C, is 12. 12 is the opposite side, and adjacent to angle C is 5. 5 is adjacent. And now, let's go ahead and remember our trig ratios. Sine is opposite over hypotenuse. In this case, that's going to be 12 over 13. Cosine is adjacent over hypotenuse, or 5 over 13. And then finally, tangent is opposite over adjacent, or 12 over 5. Okay, we'll skip over number 2, but now let's look at number 3. You'll notice in number 3, one of the issues that we begin to deal with is only 2 of the 3 sides are actually labeled for us. In number 1, we saw all 3, right? 12, 13, and 5, but we're missing this one over here, right? I'll just call this one x. Before we can begin any of the examples, we have to solve for x using the Pythagorean theorem. We know that 34 is the hypotenuse, so 34 needs to go in for c. Remember, the Pythagorean theorem is a squared plus b squared equals c squared. So we'll say x squared plus 16 squared equals 34 squared. Well, that gives us x squared plus 256 equals, if you square 34, that's 34 times 34, you're going to get 1,156. When you subtract this, you'll get x squared equals 900. And when you take the square root of 900, you find that x equals 30 exactly. So back on the diagram, I'm going to erase where it says x, and I'm just going to write in 30. Now that we've taken care of that, we can attempt each of our questions. Now, in this first column of questions, we're paying attention to angle L. So I'll circle angle L. We already know that 34 is the hypotenuse. Across from angle L, or opposite, is 30. So 30 is opposite, and 16 is the adjacent leg. Sine, if you remember, is opposite over hypotenuse. So that would be 30 over 34. 30 over 34. And that answer is fine, but we can reduce the fraction. So we'll go ahead and do it. If you divide top and bottom by 2, you'll get 15 over 17. Now cosine is adjacent over hypotenuse. That would be 16 over 34, which reduces to 8 over 17. And finally, tangent is opposite over adjacent. So in this case, that would be 30 over 16, which reduces to 15 over 8. Now, let's go ahead and try the same thing with angle M. I want you to pause the video. Go ahead and try the next 3 examples. Before you do, though, make sure to erase your circle on angle L, circle angle M, and relabel the sides. Then attempt those 3 examples. So pause the video, try those 3, and then you can check your answers against mine. All right, hopefully you had a chance to try those on your own. For sine of angle M, you should have gotten 8 over 17, cosine of angle M, 15 over 17, and tangent of angle M, 8 over 15. Okay, go ahead and turn the page. Now this is where you're going to need your calculator. These calculations cannot be done without the use of a calculator. And before we begin, we need to make sure that our calculator is in the appropriate mode, degree mode. How do we do that? Well, first thing, when you turn your calculator on, if you have a newer calculator like mine, you might see a number of words up here. And if it says degree right about here, you're in the right mode. You need to be in degree mode. If it says radian up here, that means you're in the wrong mode. Also, if you have an older calculator, you might not see any words up here. So let me talk you through how to change the mode, whether you have an old calculator or whether you're in the wrong mode to begin with. Once you're here, next to the second button, you can press the mode button. And there's a bunch of options. Usually about the 3rd or 4th option down, you can see the option of either degree mode or radian mode. If you had been in radian mode, it would look like this. If you need to change it to degree mode, just arrow over, select degree, and press enter. Okay? Then to get out of this menu screen, you just press the second button and press mode. That quits you out and gets you back here. But you want to make sure you're in degree mode. Otherwise, all of your answers from here on out will be incorrect. Okay, let's look back at the example. In the directions it says solve for x, round to the nearest tenth. And you'll notice that we cannot use Pythagorean theorem on any of these because we only know one side. We also can't use any of our knowledge of special right triangles because you'll notice none of these are 45, 45, 90, and none of these are 30, 60, 90. So we're going to have to learn something new. First thing, in number 4, go ahead and circle the 28-degree angle, just like how we circled angle L and angle M in the previous example. That's our acute angle that we're going to pay attention to because they gave us the actual measure. And now let's classify the sides. 19 is the hypotenuse, x is the opposite leg, and then this unlabeled side down here is the adjacent leg, though because it's unlabeled, we're not going to end up using it, so I'm going to cross that out. Now remember, SOHCAHTOA, SOHCAHTOA, right? Remember what each of those means. So, or sine of an angle, equals the opposite side over the hypotenuse. Ka, or cosine of an angle, equals adjacent over hypotenuse, and toa, or tangent of an angle, equals opposite over adjacent. As we look at the example given to us in number 4, we ask ourselves, what has been labeled? The opposite side has been labeled, and the hypotenuse has been labeled. Which one of our trig ratios uses opposite and hypotenuse? Well, it's sine. So here's what we should write down. We should write down sine of, this time we're not putting a letter like L or M or A or B, we're putting sine of this angle measure, 28. You don't have to write the degree symbol, but sine of 28 equals the opposite side, that would be x in this case, over the hypotenuse, which in this case is 19. Now our goal is to solve for x, so this becomes an algebra equation. We have x divided by 19 equals sine of 28. If I want to get rid of that 19, I should undo this division by multiplying both sides by 19. So that now it says 19 times sine of 28 equals x. This is what we want to type into our calculator. I don't know what sine of 28 is, but if I type in 19 times sine of 28, I should get the answer. Let's do that now. In our calculator, we type in 19 times sine of 28, and I'm going to go ahead and close the parentheses, and we press enter. You should have gotten roughly 8.9. The directions tell us to round to the nearest tenth, so that's what we're going to put. So now we can write that x is approximately equal to 8.9. Okay, let's try a few more. In number 5, we do the same thing. We circle our acute angle, and let's classify the sides. X is our opposite leg, 32 is our adjacent leg, and then this unlabeled side is the hypotenuse, though we're not going to end up using that. And we ask ourselves, okay, which sides have been labeled? Well, the opposite side was labeled, and the adjacent side was labeled. Look back at our trig functions. Which one, sine, cosine, or tangent, uses opposite and adjacent? It's tangent, right? Remember, tangent is opposite over adjacent. So we can write tangent of 41 equals the opposite side, x, over the adjacent side, 32. Just like before, x is kind of trapped in the numerator of this fraction, so we can undo this division by multiplying both sides by 32. And over here that cancels. We have 32 times tangent of 41 equals x. And this is what we want to type into our calculator. We type in 32 times tangent of 41, close the parentheses, and we get this, roughly 27.8 as our answer. So we can write x is approximately equal to 27.8. All right, let's try number 6. In number 6, we circle the acute angle, and let's label the sides. 26 is the hypotenuse, and x is the adjacent leg. The opposite leg is down here, but again, we're not using it because it's unlabeled. We ask ourselves, what has been provided for us? Well, the adjacent side and the hypotenuse. Which one of our trig ratios uses adjacent and hypotenuse? Well, it's cosine. Cosine is adjacent over hypotenuse. So we'll write down cosine of 21 equals the adjacent side, x, over the hypotenuse, which is 26. Just like before, to undo that division, we multiply both sides by 26, like so. We see that this cancels out. We're left with 26 times cosine of 21 equals x. And this is what we want to type into our calculator. Go ahead and pause the video, type that into your calculator, and see if you get the same answer as me. All right, you should have gotten x is approximately equal to 24.3 when you round to the nearest tenth. All right, for our final example, I want you to pause the video and try all of number 7 on your own. So pause the video, try it from start to finish, and then you can check your work against mine. Do that now. All right, now you can check your answer against mine. I got that x is approximately equal to 11.4. We had opposite and adjacent, so I said tangent of 55 equals x over 8. I multiplied both sides by 8, and then I typed into my calculator 8 times tangent of 55 and got roughly 11.4. Okay, that wraps up this lesson. Now that you've gotten caught up on the lesson that you may have missed, here's the homework that you missed. This was assigned over this past weekend, and so now you can work on this today. You want to turn to homework 4 in your homework packet, and specifically you want to pay attention to just these examples for today. Numbers 1, 2, 3, 5, 7, and 9. When you complete that, you'll want to go ahead and take a picture of it and turn it in on Canvas. If you have any questions, just reach out to me via Canvas or my email. Thanks for watching.